and active again. What else can I say? Yeah, again, we're really excited to have you here at GDG and excited for this talk that's happening today. Again, if you are watching this from YouTube, please do know that we have a WhatsApp channel that we allow people to go through. It gives information. We try our best to post things about tech that's happening all over Gauteng, which is where we are. Um, Post as many things that we can come across, whether it's from Google Cloud, from other events, from hackathons. So we do try to do that during our channel. So we really advise you to join our WhatsApp channel. Don't forget to follow us on all social media platforms in case you want to keep up on some news that we're having, because not too far from now we are going to be having DevFest, and we know that's very exciting for everybody to come along DevFest, and would hate for you to miss out on the news of DevFest. And maybe the lovely prizes that we'll be giving through social media platforms. So that is motivation to join our social media platform. But enough of me talking. I think let's get into our talk today. Our talk is by Lesego, which would be data storage, database, and um, serverless, which is a lab that we're going to be doing today. So I'm really excited for everybody to hear about that. I don't know, Lesego, if you're ready now.
Audible on my side?
Okay, yes, you are.
Okay, cool. Let me just share my screen. Okay, I hope you guys can see my screen now.
Yes, we can see your screen.
Okay, thanks. So, thank you to everyone for coming today again. And we'll be following up on Tuesday's session where we spoke about App Engine. So, just to sort of recap quickly for those who maybe didn't get to join the session on Tuesday, we covered App Engine. And basically, what we did in there was to use a sample app, which was developed in Python, a web app. And we essentially then deployed the application to App Engine using the Google Cloud CLI, right? And they were able to then go onto the Google Cloud platform and from the dashboard then see our app that we deployed. And then we looked at how you could debug it if you wanted to, how you could set settings for the application to scale as well in terms of when you get increased traffic or usage of the application. And essentially just to see how the dashboard works for App Engine itself. And for those who also missed out, App Engine is basically a serverless service that Google allows for different people to launch web app services that scales automatically without needing to manage the hardware directly. And that basically means without having to set the memory or the graphics card or the CPU that will be used. You essentially just set when you have a certain amount of traffic or usage that you would like for it to add another instance, right? So now, one of the advantages of App Engine that people don't know is that actually under the hood, App Engine uses Kubernetes, right? So for us able to sort of dive deeper into App Engine, we're then going to look at Kubernetes and see how the underlying architecture of App Engine actually works, so that then in future you could either continue to use App Engine, or if you want to start, let's say, getting more involved in terms of how the scaling occurs, or in terms of just the setup of your application, then you could start to use what they call GKE, which is Google Kubernetes Engine. And basically that just allows for you to launch Kubernetes apps, which are sort of similar to App Engine apps, given that they use the same underlying architecture, but they allow you to be a lot more custom in terms of the setup. So for us able to then look at that, we're just going to start to dive into Kubernetes itself. We're going to look at a few definitions of how Kubernetes works, how Kubernetes came about as well. And then we're going to look at how then can we actually launch an app on Kubernetes as well. Okay. So for those who don't know, basically Kubernetes just means ship, right? And that's why a lot of the logos is like a wheel of a ship, the captain of a ship. And the reason why that is the case is because in terms of being able to scale on Kubernetes, they look at you as basically the architecture behind the person is the pilots of the operation, pretty much. So they're basically saying that once you start using Kubernetes, you're behind the wheel in terms of managing how the application scales, right? So now, um, how did Kubernetes actually come about, right? So essentially, at the time, Google itself was obviously very famous in terms of the usage that they were having. They're having a huge amount of traffic. You can imagine the amount of Google searches that were happening. And this is pretty much in the early 2000s, going all the way into the 2010s, right? And pretty much at the time, due to the amount of usage that they were having and the demand on the web traffic, they needed to find a way to be able to scale their service, right? To basically allow for people around the world to be able to search for queries and get their answers quickly. At the time, obviously, they were using a what you call sort of a monolithic approach, which basically means that most of the servers were based in the US. So if you were in Japan or if you're in Africa and you hit a Google search, it has to go all the way across the internet to America, and then it will hit the server, and then the server will do its work, get your answer, and send it back to you, right? But now the question becomes then you don't want that to be the case when you're going to be having your service being available globally. So then at Google, they started to actually develop what they call a container orchestration system, right? Which basically just means a way to able to deploy different apps and different versions at different locations. And you would essentially set both in terms of how you want the infrastructure, meaning the underlying hardware of the server to be like. And that means you can set the graphics card, you can set the CPU, you can set memory as well, all the way to also setting in terms of the scaling aspect, which is looking at when you wanted to add more containers to be able to take in more traffic, or when you wanted to also scale down, for example, the usage drops, right? But the most important part about this was for it to be able to synchronize amongst different systems, meaning that if someone from Europe or someone from, let's say, Asia tries to search something, both of them, they shouldn't be able to have different answers. They should be able to be consistent, right? And that's where the word orchestration comes in when they say orchestration system. So pretty much after that, Google then developed Kubernetes as an internal tool to help them scale. And what this then led to was actually for a lot of new projects to start adopting um, Kubernetes. And in this file, they sort of just show you a lot of the popular projects that under the hood, they themselves actually do use Kubernetes, right? And it's a lot of the world's biggest projects. For example, you have Homebrew there, which is one of the managers for package managers for the Mac OS system. And then you also have itself, which, funny enough, is an underlying tool that you can also use with Kubernetes, and they also use it themselves, which just shows how practical it is to use for these companies and the benefits that they get from using these powerful and literally open source tools. So now this is the very, very key part that explains to our viewers what exactly is Kubernetes about. How is it structured? So when we talk about Kubernetes, we're basically saying that we want you to be able to deploy a specific version of software. And that version of software should be able to run on any computer anywhere around the world so that you can serve all of your users globally. But now to be able to understand how can you actually scale that, you need to understand the individual units that go into Kubernetes. And the first is a pod, right? So when we spoke in our session on Tuesday and we spoke about App Engine, the word instance came up, right? And an instance is basically when you have a server running. And now in Kubernetes, a pod is pretty much the same as a server. It's basically a unit of work that's occurring on a specific computer to produce the software that you essentially have written, right? And now a pod can then contain one or more containers, which is basically the versions of the software that you've written. So if, for example, let's say we had the original YouTube, right, when it essentially came out, that was the basic version that they had. And then let's say version 2 is what you wanted to deploy as well. You could essentially then deploy both of those versions of software side by side, or even more different versions, and essentially have a certain pod control the scaling of those individual pieces of software, right? So one of the important things about Kubernetes and what makes it really powerful is actually the networking effect, right? Because the only reason how software scales is if software can communicate. And now with Kubernetes, what it gives you is, given that there's so much complexity in regards to both the scaling up and scaling down of instances, meaning adding servers to able to serve your users, what starts to happen to the IP address that's being used, right? Because initially, how the world worked is if you had a server, you would then hit a specific IP address and get a specific response. But now in the cloud age, those servers are pretty much going on and off all the time, right? And the IP addresses for the computers pretty much changes as your services scale. But now with the power of Kubernetes is the fact that no matter how much scaling you have in effect, you can still just set your IP addresses to be able to communicate with other services, right? And one of the reasons why that's very important is because when you look at overall architecture in terms of an application, you're probably going to have different pieces that will communicate together, right? And if we go back to our Google example, you're going to have Google obviously scraping maybe the top 3 web results, right? And then on top of that, to the side, you're going to see Google Ads, right? And Google Ads is a different service, but it works inside of Google, right? So now that's an example of how you actually then have 2 different pieces of software communicating through a certain IP address. And that's what allows the scaling to happen in terms of having your softwares communicate to each other. So as we mentioned on Tuesday, the word service, and I think it was Mateo or Sabelo who actually answered that question very well. They said that a service is basically an individual piece of software that produces a certain outcome, right? And now in Kubernetes, that essentially is the same explanation. The difference, however, is that unlike App Engine, where you typically would have a specific URL for the app that you've launched, in Kubernetes, given that you have pods that have containers, you can actually start communicating in between different containers and pods, right? And you'll be doing that through services. Okay. So now I just want to go into a little bit more deeper, just to sort of give people a more of an understanding in terms of the overall functionalities and different components of Kubernetes and what makes it work, right? So apart from the fact that we're able to deploy individual pieces of software and obviously define how we want it to scale, how does that actually work, right? What actually happens underneath the hood for that table to occur? So when we look at the screen, we'll see that essentially we list about 5 key services that are within Kubernetes, right? And essentially, we're going to just look at them one by one and then see how we can use them in terms of architecture management. And then from there, we're going to go into GCP, the Google Cloud Platform, and then launch an example of a pod on Kubernetes. So one of the first underlying components of Kubernetes is what they call the Kube API server, right? And this essentially speaks to what we spoke about earlier on right now when we said that one of the most powerful effects of Kubernetes is the fact that it allows for networking to occur between different pieces of software, right? And now one of what we call packages that you get to use when doing that is called the Kube API server. So in Kubernetes, when you use a Kube API server, this essentially then gives you the power to then communicate between your different pods and between your different containers, right? And that's very important because one of the things that come along with it is for you to be able to firstly authenticate and authorize the user that you have on your pods or on your Kubernetes, right? Um, Before I go too deep, let me just say if there's any questions, again, you can just drop them in the chat. We'll attend them as we go to it. And I just want to drop one question just to see if everyone's keeping up. So as you can see, since we're covering the Kube API server and talking about how we can have different pods and Kubernetes containers talking to each other, can anyone explain in the chat what is the difference between authentication and authorization? Okay, I see Sabelo attempted to answer the question. Sabelo says authentication is done when checking if you are who you say you are, and authorization is checking if you are allowed access. Okay, I think that's a pretty good explanation. Pretty much, you're correct. So authentication is confirming who is the person that's doing a certain action, and then authorization speaks to the security in terms of saying who's allowed to do certain things, right? So with, again, going back to the Kube API server, you'll see that in there we can actually then set different communication protocols that can occur between the pods and the containers, and obviously then also setting what is allowed on that. Okay, so then the next key part of Kubernetes is what they call etcd, right? And basically what that is a very powerful key value pair store, which allows for essentially the orchestration between your pods and containers, right? So as we mentioned earlier on, when you set the scaling of your services by saying that, okay, if you have a certain amount of traffic, scale to 100 servers, and if it drops to a certain margin, maybe go to 10 or 15 servers, right? But now, what happens when certain servers scale down and they had critical information that was being stored or being used to serve either requests or for users, right? You do want that information to be available no matter how many servers are available at that given moment in time. So what etcd allows is for us to basically start to store different data key value pairs that can be used across the pods that we then define and scale, right? So this is very important because essentially it makes sure that no matter how many pods you have or how many servers you have running, they're all going to be pulling data from the same place. And that's very important to make sure that the data is consistent, irrespective of how much demand you actually have. Okay. The third part, and one of the most critical parts as well, is what they call the Kube Controller Manager, all right? And the Kube Controller Manager is a package that basically allows for you to define, firstly, different what they call controllers, which are responsible for different aspects that we'll get into. And then lastly, to also define the service account and token controllers that you'll actually use when running your APIs, right? So the first controller you can define is what they call the node controller, right? And the node controller is essentially, you can look at it as the master controller or the original one or the first one. And it's basically the controller that looks at when your other nodes are being scaled up or scaled down and responds to that, right? And again, as we mentioned earlier on, where you define the points at which you want your app to scale, that's where node controller will basically be looking at, right? And then the second controller we get is what they call the replication controller. The replication controller is the one that makes sure that in terms of all of your pods that are actually available, how many are actually working. Because remember we mentioned that as your application scales and also scales down, what tends to happen is that at a certain point of time, let's say you had 100 servers running and your application is scaling down to 90, the moment it actually scales down is not to say that all 10 automatically, go offline. Before the pods can be shut down or before the instances can end, there has to be a few processes that occur. And basically the replication controller is what's responsible for that. The third controller we then get is what they call the endpoints controller, right? And going back to the first package that we looked at, the Kube API server controller, the Kube API server package, is that it also works with this endpoints controller, right? In the sense that it gives the ability to talk to the different endpoints that you want the application to use when running your services. The last part is what they call the service and token controllers. And pretty much this is like more a key pair store where essentially you just be defining the API keys that you'll be using in your application when it essentially is running, right? So for example, let's say you're using Google Cloud, and then when someone requests to, let's say, log in, right, and you're using Google Authenticator, on your application, you'll have an API key that uses Google Authenticator, and basically the service account and token controller is where you'll be writing the code for your key value pairs that your application will be using. Okay, and then the fourth package that we get is what they call the Kube scheduler. Fortunately, this one is actually more, I think the word I can use is autonomous, to say that you don't actually have to write any code about the Kube scheduler. It actually just speaks to what you define in your YAML file about how you want the application to scale. But essentially, the Kube scheduler is a package that looks at how your pods scale on the platform, right? And most importantly, it comes in to make sure that the communication between your pods and containers is accurate. So the Kube scheduler is a internal tool that they added to Kubernetes to ensure that when your application either scales up or down, it ensures that the communication between the pods essentially is always consistent. Okay, and then the last controller that we get is what they call the Cloud Controller Manager, which has 4 controllers under it, right? So we already covered the node controller and we already covered the service controller, right? So we'll look at the route controller and the volume controller. So the route controller sort of speaks to the API server in the sense that it's also a package that allows for us to define the routes that we want our pods and containers to be using. So for example, let's say we are running YouTube, and on YouTube, you will probably have a repository or rather a storage bucket where all of the videos would be in this instance, right? And your route controller is essentially what you would use to point to a specific bucket or point to a specific database or whatever URL that you really want your application to use, you'll put it in the route controller. And then the last one that we get is what they call the volume controller, right? And the volume controller is what's responsible for creating and attaching and mounting volumes. And what this means in the sense of Kubernetes is basically it speaks to the memory, right? And the CPU as well. So when we go back to how the application scales, remember that we said that the difference between Kubernetes and App Engine is that App Engine scales automatically without you having to define hardware features, right? But with Kubernetes, you have the ability to define those hardware features. And essentially, the volume controller is where you can do that. Okay. So for now, I'm going to stop sharing my screen. We were just mostly looking at, the overall definitions and how everything works and the terminology that we use when talking about Kubernetes. Now we're going to go to GCP and then we're going to launch an application on Kubernetes and see the dashboard from there. So if you go to Google Cloud Skills Boost and then you search for running a containerized app on Google Kubernetes Engine, then you'll find this lab. This lab is about 40 minutes and essentially it's going to show us how to deploy the app onto GKE. So I'll attach the link for everyone else in the chat and then I'll give about 1 minute to 2 minutes for people to open it up. Okay, I just dropped the link in the chat. Okay, so what I'm going to do is stop sharing my screen. I'm going to start sharing the terminal because we're going to be doing everything through there. Okay, yeah, so currently what I've done is I've opened the repo that they give you the link to clone to, right? Which is the Python doc sample app. So what we're going to do in this instance is we're going to deploy to GKE, Google Kubernetes Engine, and then we're going to log into the dashboard and then see what's there. Okay, so one of the first things that you'll do is that you get what they call the gcloud config set function, right? And basically what this does is for you to set the region in which you want your application to run, right? So when using Google Cloud, you basically get 5 choices of regions across the world, right, for you to host your application. So the first region you get is what they call Western US, and then you get Central US, and then you get Eastern US, right? So you get 3 locations in America. And then from there, we get Western Europe, and then we get Eastern Asia. So those are the 5 regions that you get when deploying an application on GKE. SA already has a cloud region. It will be following soon. So stay tuned for that. So once you run that function, what it's going to do in this instance for us is going to set US West as our region, right? So that basically just means when we run our deploy function, our application will be running in the Western region of USA. So the first thing we have to do when running Kubernetes, or before deploying rather, is that we're going to have a container, right? So remember that each piece of software that we release essentially is a container, which is inside a pod, right? And that's what we deploy. So in this instance, we're going to just create a container and call it hello world for the purposes of this demonstration. And the function that we use to create a container is basically gcloud container clusters create. I'll do that for you guys. Okay, let's see why did I get an error. Okay, so I need to check on GCP, on Google Cloud Platform, if I've enabled GKE. Let me double check. Oh, I see Sabelo has a question. He says, is US West a recommended region to use when you're in South Africa? I think I would suggest I think it's, let me just double check the exact name. I just know it's the European one. So the region I would suggest is Western Europe, because pretty much Europe is closer to Africa than USA. So the ping time to the servers will be a lot quicker. So the options that you get under Western Europe is Europe dash West 1. Yeah, that's the option that I would use. Again, on the labs, you're able to see all the options as well. Okay, so let me go back to Google Cloud Platform so you can see how we're going to enable the API for GKE, and then we'll come back to the terminal. Okay, so you're just going to follow what I'm going to do, right? So currently, instead of using the CLI table to create the cluster, since on GCP for me to enable it, it already essentially gives me the UI. We're just going to do it that way and then come back. So let me firstly just skip a few parts. Okay, so as you can see, it gives a bit of a description about what we spoke about earlier in terms of the different controllers, right? So for here, we get the name autopilot cluster 1, and then here's the regions that we spoke about right now. So I'll just use Europe West 1, just as an example. And I press create. I'm not sure if you can see, it says submitting there. Okay, so as you can see, it's pretty much configuring the initial cluster, all right? I'm sure you could probably also hear my laptop fans right now running very hard. So it takes about maybe 2 to 3 minutes for it to completely set up the cluster. Okay, so now it's done configuring the pod. It's going to now deploy the pod. Okay, so whilst we wait for this to finish, let's quickly just look at the options that we get within the Kubernetes engine, right? So the first part, which is currently what we're creating, is a cluster, right? So as we spoke earlier on about how you can deploy different versions of software at the same time and have them controlled under a pod, a cluster is basically a centralization of pods. So having multiple apps running, right? And that's what goes back to the whole orchestration purpose of using Kubernetes. The second part is what you call a workload. So a workload is what we're familiar with and what we explained in App Engine, which is basically a instance of the application running. So on Kubernetes Engine, when we come to workloads, it's going to show the individual instances running at that time. And then teams is where, when we go back to what we spoke about in regards to the controller and the scheduler that we have available to us in Kubernetes, one of the things you can also do, especially now in the whole age of AI agents and everything, is that you can essentially create different workflows that you want to have to work synchronously or to work in terms of having a certain input and output. So like having a stream flow. So you can say if you want, for example, one cluster, let's say to work on maybe, let's say, compressing certain footage or transcoding footage. And then you can have another cluster, let's say focused on being, or rather on caching memory for serving content quickly. Maybe then you have a third cluster, which is maybe running a machine learning cluster to sort of learn people's favorite, let's say, videos or music taste or whatever. And essentially then have those three different classes together. So under teams is where not only do you have the classes that you defined, but then you can define in terms of how you want them to work together. And then applications is pretty much into clusters, but what it allows for us is to actually have more settings in terms of, firstly, the endpoints that we want to have within our GKE, within our Google Cloud Kubernetes engine. And then also as well to make sure that in terms of setting up firewalls. So remember that we spoke earlier on about how one of the powers of Kubernetes is the fact that networking gives you the ability to communicate with other services, right? So now with applications, it gives you more granularity in terms of the firewalls you can set up for that. And also just pretty much any, let me say, load balance management for the application as well. And then we get into the AI and ML. Pretty much it's still the same as a cluster, but what they then did here was to actually then run specific hardware under the hood. So pretty much, as we all know, when it comes to AI and ML, GPUs are all the craze. So when you click on AI and ML, whenever you create a cluster, it's going to be using a GPU, right? So typically when you create a normal cluster, you probably won't need a GPU. You're just going to be using your CPU and your RAM and your space, right? That's pretty much all you're going to need. But once you run a GKE cluster on AI or ML, is then going to incorporate a GPU. And yeah, you'll pretty much see that on the bill. From there, you get secrets and fig maps. And I think we about this as well. Sabella did ask about it on Tuesday in terms of options where to store your secure codes or your secret passwords or anything. And at the time, we said we have Secret Manager, which is an individual service that Google has on Google Cloud where you can keep passwords. But then when it comes particularly to GKE, you can then use this specific part, which is called secrets and config maps. And this is where you'll put, your passwords and any key value pairs that you want your application to use, right? And then storage is pretty much as basic as it sounds, where you just bucket and the size that you want. And again, remember that we said that since Kubernetes allows automatic scaling, you can set a storage for it to communicate with. So going back to our YouTube, if all of your YouTube videos for a certain channel are sitting in a specific bucket, then you're going to have that bucket sitting in the storage part of here in GKE for that cluster to then draw from, right? And then object browser, I think that's one I'm not too sure about. I haven't seen that. I might need to Google that one. And then backup for GKE, pretty much similar to storage as well. And then security and policy. So these ones, I would say you can use them, but then if you really go back to the packages that we looked at that are within Kubernetes, you can still use the controllers to actually control the firewalls and any security policies that you want to set. So This one is more UI based, but you can still do it through the code if you wanted to. And the same goes for what's under networking. So you get gateways and services, and you also get network function. So if you remember when we spoke about the packages within Kubernetes, and we had the Kube API server, this is basically that functionality. But then in here, it's just through the UI, right? So I think our server has spun up. Let's see. Okay, so yeah, our server has spun up now, right? As you can see, status is ticked, it's 100% healthy. Remember, we said earlier on that, for example, if we make an example going back to YouTube, let's say we had 10 containers, right, running. And let's say those 10 containers were for a country each, right? So let's say we had one in SA, let's say we had one in Brazil, or China. So let's just use those three for now, for example, right? If one pod was to go down, you would only have two available, right? And essentially then your healthy would go down to 66% because at that point in time, given that one of your three is out, then you've essentially lost the 3% of your capacity. So the health essentially speaks to how many of your pods are available at that time. So when you come to the second tab called utilization, you'll see that, so we get quite a few number of options, right? So we already chose our location as Europe West. The type is GKE, Kubernetes. And then when you come to CPU, right? Again, this will show how much of the CPU is being utilized by the certain pod that you're running or the cluster that you're using. But what I want you guys to see is these two parts here, the memory and the disk, right? So remember we said that what powers with Kubernetes is that you can actually then set how much memory, this is like RAM, that you want your system to use, along with the actual storage space, the disk that you can configure for that Kubernetes cluster, right? So in this instance, given that we just created a normal cluster, it didn't come with any memory or disk. But if we wanted to define how much memory we wanted, meaning RAM, or how much or how much storage we wanted, excuse me, you could do that too as well. So pretty much observability goes back to a combination of the overview and utilization, but it just does it through more a graph structure. This would only be really relevant when you have either a high amount of traffic or if you're looking to analyze the logs of, let's say, recent traffic that you had. But it's pretty much everything that we just took a look at under utilization, just in a graph format. So I just want to go to the AI and ML, and then we'll close it off. I just want to see if I can play my sound as well. It's a quick 2-minute video. Let me know if you can hear the sound.
Hi everyone, welcome to this video where we'll explore how GKE can help you build a powerful artificial intelligence and machine learning platform in Google Cloud. Before we continue, you should have a basic understanding of Kubernetes concepts, machine learning, and the model development lifecycle. Now let's talk about GKE. GKE is a managed Kubernetes service that makes it easy to deploy, manage, and scale your AI/ML workloads in the cloud without needing to be a Kubernetes expert. Here's how GKE simplifies your AI/ML journey. Imagine a medical imaging company called QuickScan. They are training a deep learning model to detect early signs of cancer in X-ray images. They have a massive data set and need to train their model fast. Using GKE and the Ray framework, QuickScan can distribute the training workload across multiple machines, significantly speeding up the process. QuickScan's team wants to improve collaboration and experiment tracking. GKE enables them to easily migrate their Jupyter notebooks from their local machines to a hosted environment, allowing them to work together, share code, and visualize results seamlessly. Now let's look at another example. A customer support team wants to automate responses to common questions using a conversational AI chatbot. They need a chatbot that can understand natural language and provide accurate and helpful responses. To create the chatbot, the support team uses Gemma, a popular language model. Since they already use GKE for other tasks, they build the chatbot using their existing GKE infrastructure. This gives them more control and helps them understand the chatbot architecture, thanks to tools like retrieval augmented generation. These examples highlight how GKE's flexibility, scalability, and support for popular machine learning frameworks and tools make it a powerful platform for bringing your AI innovations to life. To learn more, check out our documentation. Thanks for watching.
Okay, so pretty much that was just explaining what GKE and how it works with AI ML. Pretty new to it myself. I haven't actually seen that, so I'll probably spend some time here as well. Before closing off, I just want to go back to the lab just to show you guys what you guys need to do in terms of submitting your screenshots, and then we'll close it off. Okay, so basically this is the part that we went back into the Google Cloud platform for, right? But pretty much everything that we did there, same thing you can do here, but through the CLI, right? Which is what the lab wants you to do. So pretty much once you've deployed your application, on the fourth step, you'll see that there's a very key function that we get, which is called kubectl get deployment, right? And essentially, this will show all of the pods that we have running on GKE, right? So in terms of the lab, once you have completed the lab, please do make sure to use that key function, right? So just to go back to it, task 4, right? So you create your deployment, and then once you deploy it to GKE, you can then use the kubectl get deployments function to then pull the application that you deployed to GKE. Do take a screenshot of this part, because that's what will prove to us that you've been able to actually deploy the application on GKE. And then from there, you'll be able to access it using this function, kubectl, which will give you the IP address of the application that you deployed, right? So even if you check on the Google Cloud platform, once you're going through it and you're on the platform via the lab, you'll see that you'll be able to go to the dashboard and see the exact same data that you have here, just in the CLI, right? So the difference is once you've completed deployment, you can then actually access the application over the internet. And as you can see here, it'll then say hello world, version 1.0, and the host name will be different per user at the end, right? And then take a screenshot of that. So just take 2 screenshots, which is CTL get deployments, which will show all of the apps you've deployed, which will be 1 app in this instance for the lab. And then take a screenshot of you having accessed the application on Chrome or any browser, and then it'll show the application running, and then take a picture of that as well, and send in those 2 screenshots, and that'll be the completion of your tasks. So yeah, I think thank you to everyone for joining. Thank you for giving us your time to explain Kubernetes to you in the best way that we can. And I think you guys have up until Tuesday, if I'm not mistaken, to submit your work. And then from there, after this talk, the talk will be uploaded onto YouTube for you guys to review as well. Okay, I see Sabel has a question there. He says, can you discuss how you choose services for deploying a monolith versus microservices? Okay, Um, Pretty much, I think what I would say about that is it sort of goes back to how big your application is, right? So typically, I'll take Google as an example. When the application started, you can imagine it was just like them trying to make you put a word in a box and then get a result, all right? Sounds very simple, but there's a lot of code that goes into that. And they could write that monolith, right? Because it was, I don't want to say a little bit of code, but a specific number of lines of code, right? But you can imagine Google's code base right now. It's totally ridiculous. It's massive. There's millions of lines of code, right? So the point is that once your project has more and more and more code in it, you need to start breaking it up, right? So that firstly, you can actually start detecting where bugs come from. Secondly, going back to the whole purpose of what microservices are, which is to ensure that each function of the software is running individually, right? So that it can scale effectively. So the main point I'm trying to make is once you start having a large code base is when you'll start using microservices. And once you start using microservices, that's when you start using App Engine or GKE or any other of that like, or Cloud Run as well. But once you beginning or starting out, your code base will probably be monolith and you'll probably default to using even still those services or just easier deployment options as well. Okay, I see Bumalelo asks, what are we submitting? So if you go to the lab under task 4, which is pretty much the last task in the lab, there's a function that says get deployments, kubectl get deployments, where after running that, it'll show you all of the apps that you've deployed on GKE. You just take a screenshot of that. And then after that, you can actually access the application you've launched on GKE on the browser. And once you do that, it'll say hello world version 1, and it'll include the specific, let me say, workload instance number that you launched on. And then you take a screenshot of that. So it's pretty much a screenshot of kubectl get, which will show you deployment, and then a screenshot of you actually accessing the application. So it's just those two screenshots. Okay, thank you so much. Thank you to Sabelo again. Yeah, it was very great to spend today's time on Kubernetes. Thankful for the questions as well. If you do need any help in terms of the labs or anything difficult comes across, of course, to reach out to us through any social media, and we'll be in touch there. And yeah, I wish you guys all the best. Do enjoy the rest of your evening as well.